Every action you're taking right now, blinking, breathing, swiping your screen, even that sudden thought popping into your mind. Should I keep watching? These moments that seem entirely under your control may have been written into some script you'll never see. Back in that single second of the Big Bang 13.8 billion years ago. Sounds like a fortune teller's trick. Quite the opposite, this is physics' most ruthless underlying logic. Picture this scene. A late-night pool hall, the air thick with tobacco and wood wax. Dim yellow light casting sharp shadows across the deep green table. A professional player stands before the table, eyes closed. Having already completed all calculations in his mind, the angle, force and spin of the cue ball, even the table's nearly imperceptible tilt. The moment the cue strikes, 1,000 colored balls begin performing a precise dance across the table. If you possess enough data, the mass, position, force, direction, air resistance coefficient, and table friction of every ball, you could predict the exact final position of each ball 10 seconds later, the instant the cue touches the cue ball. Error, virtually non-existent. Now magnify that billiard table. Expand it to the scale of the entire universe. 13.8 billion years ago, the Big Bang was that single stroke. And you, your body, thoughts, desires, fears, dreams are merely one of the billiard balls rolling along its predetermined path. What chills the blood even more is this. The very impulse to refute me right now, the facial muscles twitching as you frown. The speed your fingers unconsciously swipe across the screen. Even the rhythm of your accelerating heartbeat, all are ripples from that single shot. You think your brain is actively thinking. Wrong. It's 86 billion neurons colliding without a shred of uncertainty, obeying electrochemical laws. You needn't participate in this process at all. Like dominoes, the moment the first one falls, the fate of the last is already etched in the stone tablet of time. Someone once conducted a wild thought experiment. If there existed a supercomputer with infinite processing power, and if you could feed it every piece of information from the moment of the universe's birth, the position of every quark, the flow of every energy strand, the fluctuation of every field, then this machine could predict every single decision you'll make in your lifetime, including whether you'll keep reading this or swipe away. It would know what time you'll fall asleep tonight, what dreams you'll dream. It would know if you'll suddenly remember someone long forgotten in the dead of night, then toss and turn until dawn. So the question arises, if everything is predetermined, are we truly alive? But wait, the answer to this question is far crazier than you could imagine. Winter, 1814, Paris. Snow still clung to the banks of the Seine, a thin frost coating the streets. In his study, crammed with manuscripts and astronomical charts, French mathematician Pierre-Simon Laplace sat by the flickering firelight. With a quill pen, he penned a hypothesis that would silence the scientific world for generations. He posited, if a being existed that knew the precise position and velocity of every particle at the moment of the universe's birth, then for that being, the future would be as transparent as the past. Nothing would be uncertain. Nothing would be unforeseeable. The entire evolution of the cosmos would unfold like a script already written, unfolding step by step. This hypothetical entity would later be dubbed the Laplace's demon. Sounds like mythology. No, it was pure mathematical reasoning. Newtonian mechanics had already demonstrated that knowing an object's initial position, velocity, and forces acting upon it allowed precise prediction of its location 1 second later. The trajectory of an apple falling from a tree could be calculated. The arc of a cannonball's flight could be predicted. The path of the moon orbiting Earth could be deduced. The trajectory of an apple falling from a tree could be calculated. The arc of a cannonball's flight could be predicted. The path of the moon orbiting Earth could be deduced. The trajectory of an apple falling from a tree could be calculated. The arc of a cannonball's flight could be predicted. The path of the moon orbiting Earth could be deduced. Then isn't the universe just an aggregate of countless particles? Theoretically, everything can be calculated. This theory shocked everyone at the time. What did it imply? It meant that yesterday's argument with your lover might stem from a childhood experience of being overlooked. Today's hesitation between Sichuan and Cantonese cuisine when ordering lunch was shaped by the combined influence of childhood taste memories lingering on your palate and last night's food videos. The city you'll relocate to after quitting your job next year depends on the concentration of neurotransmitters in your brain and the cumulative effect of external stimuli. All of it is a program compiled 13.8 billion years ago. You think you're making choices. No, you're merely executing an algorithm that began running at the universe's birth. Even your impulse to refute this notion is just the inevitable result of trillions of neurons discharging according to physical laws. Your anger, doubt, and resentment are nothing but chemical reactions. What's even more astonishing is how terrifyingly precise this theory manifests in the real world. In the 18th century, British astronomer Edmund Halley used Newton's laws to calculate a comet's orbit. He predicted its return in 76 years with astonishing accuracy. On Christmas Day 1758, when the comet later named after him appeared precisely in the night sky, Europe's astronomical community was stunned. The error was less than 1 second. In 2015, NASA's New Horizons probe reached Pluto after a 9-year journey spanning 4.8 billion kilometers from Earth. This mission relied on the same equations Newton wrote over 3 centuries ago. The trajectory calculated at launch deviated by less than 1 kilometer after 9 years, at a scale of 4.8 billion kilometers. This precision is equivalent to shooting an arrow from Beijing to New York and hitting a coin dead center. The GPS system in your phone constantly corrects time errors using Einstein's theory of relativity. Because satellites orbit at extreme speeds in space, time flows differently for them than for you on Earth. Without this correction, your navigation would drift over 10 kilometers in a single day. But with relativistic adjustments, your positioning accuracy remains within meters. The laws of physics never falter. They are cold, precise, and unforgiving. If they can predict planetary orbits and send probes to the edge of the solar system, why couldn't they predict your life? Isn't your brain also composed of atoms? Aren't your thoughts merely the transmission of electrical signals? Aren't your emotions fluctuations in hormone levels? Fundamentally, what essential difference is there between you and that planet orbiting the sun? Just as everyone was about to accept the harsh reality that the universe is a precision-engineered machine, quantum mechanics suddenly overturned the entire table in the early 20th century. March 1927, University of Göttingen, Germany. 25-year-old physicist Werner Heisenberg sat in his cramped apartment, gazing out at the gloomy sky and lost in thought. He had just completed a calculation whose results unsettled him. Weeks later, when he shared this discovery with the world, the entire physics community plunged into unprecedented debate. This was the famous uncertainty principle. Heisenberg declared that it is impossible to simultaneously know the exact position and velocity of a particle. Note, this isn't due to inadequate measurement technology or imprecise instruments. The fundamental code of the universe itself prohibits it. The more precisely you attempt to measure position, the more uncertain velocity becomes. The more you strive to pin down velocity, the more elusive position grows. It's like trying to photograph the same person's face from both front and back simultaneously, physically impossible. It's not that the camera isn't good enough. The very act is logically impossible. This discovery sent shockwaves through the entire physics community. The Laplace's demon premise hinged on precisely knowing the position and velocity of every particle. Now Heisenberg tells you, God has built a wall at the universe's foundation, and you can never cross it. Before the dice hit the table, the outcome is truly uncertain. It's not that you can't calculate it, it simply hasn't been determined yet. Even stranger phenomena lie ahead. In the quantum world, a phenomenon called superposition exists. It describes a particle existing in all possible states simultaneously before observation. It is both here and there. It spins both left and right. All possibilities coexist until the moment of observation. when it collapses into a definite state. Austrian physicist Erwin Schrödinger was deeply dissatisfied with this theory. To satirize this absurd notion, he devised a famous thought experiment. A cat is sealed in a box containing a radioactive atom, a detector, and a vial of poison. If the atom decays, the detector triggers a mechanism that shatters the poison vial, killing the cat. According to quantum mechanics, before opening the box, the atom is both decayed and undecayed, so the cat is both dead and alive. Only at the moment of observation does it decide its state. Schrödinger originally intended this absurd example to prove flaws in quantum mechanics, but it ironically became its most famous metaphor. Though it sounds like science fiction, it describes a real physical phenomenon. In 2019, Google announced achieving quantum supremacy. Their quantum computer completed a calculation in 200 seconds that would take a classical computer 10,000 years. This machine operates by placing quantum bits in a superposition state of both 0 and 1 simultaneously, enabling parallel computation. Quantum computers from IBM, Microsoft, and the University of Science and Technology of China process data daily using this bizarre principle. This isn't theory, it's a reality that can be repeatedly verified. So the question arises, if every atom composing your body carries fundamental uncertainty, how could your life possibly be predetermined? If electrons lack a fixed position before observation, how could the particles forming your brain's neurons follow predetermined trajectories? People glimpsed hope, believing free will was finally saved. Quantum randomness seemed to carve space for our choices at the universe's deepest level. But scientists supporting classical determinism immediately launched a counterattack. And this counterattack was devastatingly lethal. They argued that quantum uncertainty only applies in the microscopic realm. In the macroscopic world, this randomness gets averaged out by the sheer number of particles. Just as flipping a coin once might land heads, flipping it 100 million times will yield heads and tails at exactly 50% each, with an error margin not exceeding 1,000th. This is known as the law of large numbers, a fundamental principle of statistics. Your brain contains 86 billion neurons, each connecting to an average of 7,000 others. Each neuron itself contains countless atoms. We're talking about a quantity on the order of 10 at such terrifying scales. Quantum randomness is long since smoothed out by statistical laws. Consider a glass of water. Countless water molecules perform Brownian motion, each following a random trajectory. Yet macroscopically, the water appears still. Properties like temperature, pressure, and density are deterministic and precisely calculable. At the macroscopic level, what must happen will happen. Your brain operates the same way. Moreover, they present an even more radical argument. Even if quantum randomness did influence your decisions, it wouldn't equate to free will. Randomness is not freedom. Imagine deciding what to eat today by flipping a coin. Heads means hot pot, tails means Japanese cuisine. The moment the coin lands, the outcome is set. You go for hot pot. Is that your free will? No, it's leaving things to chance. You've simply handed the decision over to a random process. True free will should be I eat whatever I want, but the question is, why do you want this and not that? True free will should be I eat whatever I want, but the question is, why do you want this and not that? Is it the warm memory of that hot pot your mom made when you were a kid? Was it seeing a food blogger eating hot pot while scrolling through short videos yesterday? Is it the cold weather today, making your body instinctively crave calories? Or is it because your blood sugar is low, and your brain released some hormone making you crave high-calorie food? Or is it because your blood sugar is low, and your brain released some hormone making you crave high-calorie food? Every want has a reason behind it, and every reason has an even earlier cause. Your childhood memories stem from your upbringing. Your upbringing depends on your parents' choices, and your parents' choices depend on their own life experiences. Trace it back layer by layer, and you'll eventually reach the moment of the Big Bang. Like a river, you see the ripples on the surface. But what shapes those ripples is the riverbed's terrain, the wind's direction, the water's flow. And these factors are determined by even earlier ones. Trace it back, and every now is the inevitable result of countless pasts. But it doesn't end there. In 2008, Benjamin Libet, a neuroscientist at the University of California, conducted a series of experiments that made everyone extremely uncomfortable. The design was simple. Subjects sat before a sophisticated electroencephalograph EEG machine, facing a button and a clock. They could press the button at any moment, while memorizing the clock's position at the instant they decided to press it. The equipment recorded to time points. The moment the subject reported, "I decided to press the button," and the moment the readiness potential, a brainwave signal associated with preparatory movement appeared in the brain. The results stunned everyone. A neural response corresponding to the button press appeared in the subject's brain 0.35 seconds before they consciously decided to press it. Some experiments extended this time gap to as much as 7 seconds. In other words, 7 seconds before you realize I'm going to press the button, your brain has already begun preparing for the action. Put simply, your brain makes decisions before your conscious awareness catches up. You think you decided to press the button. Actually, your brain initiates the neural program first. Only after a series of complex biochemical reactions does it notify your consciousness. Hey, you just decided to press the button. What does this mean? It means your consciousness is merely an observer, informed after the fact. It's like a company board meeting where all decisions are made before. HR emails you, "We've finalized next quarter's strategy, just letting you know." You weren't part of the decision-making process. You think you're actively thinking, but you're really just passively receiving your brain's work report. And why did your brain make that decision? Because of the strength of neural connections, neurotransmitter concentrations, and hormonal fluctuations. What determines these? Your genes, your experiences, your current physiological state. What determines these? Your parents' genes, your upbringing, the food you eat. Peel back layer by layer, and you won't find a single decision-making starting point that truly belongs to you and remains unaffected by external factors. This realization is so brutal that many philosophers still desperately seek counter-arguments. Some suggest consciousness and brain activity might occur simultaneously with only a perceptual delay. Others propose free will lies not in initiating actions but in rejecting them, that you can change your mind at the last moment. But these counter-arguments ring hollow. For isn't changing one's mind itself a brain decision? And doesn't the neural activity behind that decision occur before you become aware of it? So who is right? Classical determinism or quantum randomness? The answer may be crazier than anyone imagines, because this isn't a binary choice at all. Time might not exist at all. April 18, 1955, Princeton. Einstein lay in a hospital bed, his life entering its final countdown. Days earlier, his dearest friend Michel Bessot had passed away. This engineer who once discussed relativity with him at the Swiss Patent Office. This companion who walked alongside him through most of life's journey had departed this world before him. In a letter to Bessot's family, Einstein wrote, "For those of us who believe in physics, the distinction between past, present, and future is only a stubborn illusion." This was not consolation, nor poetic rhetoric. It was the stark conclusion he drew from general relativity. General relativity reveals that time is not a river flowing from past to future, but a static four-dimensional map. Physicists call this the block universe theory. In this model, past, present, and future exist simultaneously within spacetime like different pages of a book. You are not moving toward the future. You are merely moving your consciousness along the timeline, frame by frame, playing the movie of your life. The film reel has always existed. Every scene has already been shot. You are simply experiencing it from beginning to end. What does this mean? It means your birth, first love, graduation, marriage, divorce. and death are all pinned like landmarks on the four-dimensional spacetime map. They've been there since the moment the universe was born. That afternoon in third grade when you stared blankly at your desk, sunlight streaming through the window onto your textbook, the scent of spring grass filling your nose, that very moment still exists. Just at another point in the spacetime coordinates. The scene of you scrolling through your phone late at night at age 25, the blue light from the screen illuminating your weary face, your heart racing with anxiety, that scene also still exists. The moment at 70 when you sit in the sunset recalling the past, the fading light painting the sky crimson. Your memories flooding in like a tide, this moment already exists now, though your consciousness hasn't yet played that frame. They are not once existed, currently happening, or yet to come, but simultaneously present at different coordinates in spacetime. Just as different streets of a city coexist, different moments of your life also exist concurrently. If this is true, then determinism isn't predicting the future, it's describing reality. The future isn't about to happen. It's already there waiting for you, just not yet played back in your consciousness. Like the ending of a movie, it was filmed long ago, but you, sitting in the theater, haven't seen it yet. But this raises a hair-raising question. If everything already exists, if the future is as real as the past, why do we feel time flowing? Why does now feel special, uniquely real? The answer lies in a concept called entropy. Entropy is a physical quantity in thermodynamics that measures disorder. In the 19th century, physicist Rudolf Clausius formulated the second law of thermodynamics. In an isolated system, entropy can only increase, never decrease. This law is chillingly cold, for it implies the universe has a direction. Ice melts into water, but water never spontaneously freezes into ice. Hot coffee gradually cools, but cold coffee never heats itself. Break an egg and the liquid spreads everywhere, yet it will never reassemble itself into a whole egg. A tidy room grows increasingly messy, but a messy room never tidies itself. These are all processes of entropy increase. From order to disorder, from low entropy to high entropy, this is the one-way street of cosmic evolution. The entire universe is one vast system of increasing entropy. At the moment of the Big Bang, the universe existed in a state of extremely low entropy, with all energy concentrated at a single point, highly ordered. The subsequent 13.8 billion years of evolution represent a continuous increase in entropy. Stars burn, dispersing energy. Galaxies collide, scattering matter. Black holes devour, erasing information. The universe grows increasingly disordered and chaotic. Our brains function as the hard drives recording this process. The brain's operation relies on entropy increase. Neurons consume energy to transmit signals, and this energy expenditure generates entropy. The brain can only record information from low entropy to high entropy states, because memory formation itself is an entropic process. Establishing new neural connections consumes energy, generates heat, and increases disorder. Therefore, we can only remember the past, not the future. It's not because the future hasn't happened yet, but because our memory mechanism is inherently designed to operate only along the path of increasing entropy. This creates an illusion that makes us feel time is flowing, that now is special, that the past is fixed, and the future is uncertain. But in reality, time is not a flowing river. It is a map spread out before us. It is our consciousness moving across this map, following the direction of increasing entropy that creates the illusion of flow. It's like watching a movie in a theater. The film itself is static, with every frame existing simultaneously on the reel. It's the projector, advancing frames at 24 per second, that creates the illusion of motion. Your consciousness is that projector, playing your life along the timeline and manufacturing the illusion of time's flow. Within this framework, does free will still exist? If your entire life is already fixed like film stock, predetermined from the moment the universe was born, and you are merely experiencing it frame by frame, do you truly have any choice? Quantum mechanics offers an even more mind-bending answer: parallel universes. In 1957, American physicist Hugh Everett proposed the many worlds interpretation of quantum mechanics. This theory states that whenever a quantum event occurs, the universe splits into multiple parallel worlds. Every possible outcome is realized in a different universe. It's not that the quantum state collapses into a single result, all possible outcomes occur, just in different branches of the universe. Schrodinger's cat dies in one universe and lives in another. Both universes are equally real, yet each remains unobservable to the other. The universe where you chose Sichuan cuisine for lunch today coexists with the universe where you opted for Cantonese cuisine, both equally real, merely residing in separate branches. On this timeline, you read this text, gave it a thumbs up, and shared it with friends. On another timeline, you never clicked this video at all. Instead, you scrolled through short videos for a while before going to sleep. On a third timeline, you swiped away halfway through because it felt too mind-bending. On a fourth timeline, you watched it all the way through and fell into deep contemplation, staying up all night. Every possibility unfolds, scattered across countless parallel universes. What does this mean? What does this mean? It means classical determinism and free will can coexist. Within your specific universe branch, everything is indeed predetermined. From the moment of the Big Bang, this branch's evolutionary path was set. Your choices were already written in this branch's script. Yet across the sum of all universe branches, every possibility is realized. In one universe, you became a writer. In another, a programmer. In yet another, you chose a completely different life path. You have no freedom to choose which branch to inhabit, but every version of you truly exists, living utterly distinct lives. It's like playing a game with multiple endings. At every critical choice, the game autosaves and branches into multiple paths. You experience only one storyline, yet all paths are real. In one version, you confessed to the person you liked on a rainy night. You got together, experienced passionate love, arguments, reconciliations, and marriage. In another version, fearing rejection, you remained silent that night. You watched that person end up with someone else, regretting it alone late into the night. In yet another version, you never met that person at all because you chose to turn left instead of right at a certain intersection, completely altering the trajectory of your entire life. Each version is equally real, each playing out a complete life within its own universe. By now, you might be completely baffled. Classical determinism, quantum randomness, block universe, parallel worlds. These theories sound contradictory, yet each rests on solid mathematical and experimental foundations. This isn't science fiction. It's the cutting edge of contemporary physics. Humanity's current physics is this fractured. This bizarre. Humanity's current physics is this fractured, this bizarre. At the microscopic level, quantum mechanics reigns. Particles can exist in multiple places simultaneously, traverse impassable barriers, and instantly influence distant counterparts. At the macroscopic level, relativity governs. Time dilates or contracts due to speed and gravity. Space warps under mass, and light bends along curved paths. Both theories are extraordinarily precise and have been validated by countless experiments, yet they remain irreconcilable. Quantum mechanics yields absurdly infinite results when describing gravity, while general relativity breaks down entirely when applied to microscopic particles. Physicists call this the crisis of the Standard Model. Weinberg have all sought to discover the ultimate theory unifying everything. String theory, loop quantum gravity, the holographic principle. M-theory, one bold idea after another has been proposed, only to be partially disproven or run into dead ends. So far, no one has succeeded. Perhaps reality is stranger than we can imagine. Perhaps we are like Neo in the Matrix, living within a higher dimensional system beyond our comprehension, perceiving only shadows projected onto three-dimensional space. Perhaps our universe itself is merely a quantum state within a larger system, a computational process, a holographic projection. Perhaps free will and determinism aren't opposites at all, but different manifestations of the same phenomenon across varying levels. Just as light is both wave and particle, both deterministic and random, this isn't a contradiction, but the very essence of the world. But do you know what's most fascinating? Even if everything is truly predetermined, even if your life was written into the universe's source code 13.8 billion years ago, your life still holds meaning, because the experience is real. The people you've loved, that heart-racing, cheek-flushing sensation where the whole world brightens, it's real. The tears you've shed, that grief washing over you like a tide, your chest feeling crushed by a boulder, the pain making breathing difficult, it's real. The moments you've laughed, that joy welling from your core, muscles twitching uncontrollably, tears welling in the corners of your eyes, it's real. The dreams you've had, those absurd, beautiful, terrifying ones that wake you in the night or leave you smiling, they are real. These feelings don't lose their value simply because they were predestined. It's like watching a movie in the theater. You know the ending is already filmed, the protagonist's fate long decided, every plot twist planned months ago by the director and screenwriter. Yet you still feel moved, laugh, cry, tense up, agonize over the character's choices. After the credits roll, you walk out, those emotional ripples still echoing within you, shaping your mood and thoughts for days to come. The authenticity of this experience doesn't vanish just because you know it's only a movie. The meaning of life lies not in whether you can rewrite the script, but in how you experience the story. An actor given the same script can deliver a brilliant performance or a forgettable one. The script is static. The performance is dynamic. Moreover, you can never know your own script in advance. No Laplace's demon, no supercomputer can predict your future. Quantum uncertainty is just one reason, chaos theory is another. In the late 19th century, French mathematician Henri Poincaré uncovered a terrifying truth. Even within the deterministic realm of classical mechanics, minute differences in initial conditions can lead to vastly divergent outcomes. This is the famous butterfly effect. A butterfly flapping its wings in Brazil could potentially trigger a tornado in Texas. This doesn't mean the butterfly literally caused the tornado, but rather that weather systems are highly sensitive. An error in initial conditions as small as 1 in a billion can, after several days of evolution, yield completely different predictions. That's why weather forecasts beyond 2 weeks are largely unreliable, not because our computers aren't fast enough, but because we can never obtain sufficiently precise initial data. Your brain is also a chaotic system. 860 billion neurons, each connected to thousands of others, form a network more complex than the entire internet. A tiny fluctuation in a neurotransmitter molecule, amplified through this network, could alter your perspective on something, thereby changing your decisions and ultimately your life's trajectory. Add quantum uncertainty to the mix, plus your inability to process all external inputs, the expression of a stranger you glimpsed yesterday, the way leaves rustled in the wind, the play of light on water at a fleeting moment. These seemingly insignificant details subtly shape your brain's state. So even if the universe were deterministic, even if your life were theoretically predictable, no system could actually achieve this. Your life remains forever unknown to you. That is enough. In subjective experience, you remain free. You don't know what tomorrow will bring, whom you'll meet in this lifetime, when sudden enlightenment might strike, which words will shift your perspective, or which moments will become eternal in your memory. This very uncertainty is a form of freedom, for in your unforeseeable future, anything is possible. More crucially, regardless of whether determinism is true, your choices remain significant. Because your choices become part of those prior causes. Your decisions today influence tomorrow's outcomes, and tomorrow's outcomes shape the day after. This chain of causality doesn't lose meaning simply because it's predetermined. On the contrary, precisely because every cause inevitably produces an effect. Each of your choices becomes profoundly significant. Consider this. Those physicists who embraced classical determinism were often the most relentless. Einstein believed the universe was deterministic. God does not play dice. Yet this conviction did not deter him from dedicating his evenings after patent office work to physics research, ultimately leading to his world-changing theory of relativity. Stephen Hawking believed physical laws govern all, yet he persisted in research despite being completely paralyzed, writing a brief history of time that influenced generations. Richard Feynman trusted the iron laws of quantum mechanics, but his passion and creativity for physics made him one of the greatest physicists of the 20th century. They all understood that today's efforts are the seeds of tomorrow's success. The chain of causality never deceives. Read one extra page today, and your brain forges new neural connections that shape tomorrow's thinking. Practice an extra hour on the piano, and your fingers develop deeper muscle memory that elevates your next performance. Ponder one more question today, and your cognitive framework grows more robust, enhancing your ability to solve future problems. Each of these becomes a prerequisite for some future moment, a link in the chain of cause and effect. That's why every choice you make matters not because they are free, but because they have consequences. So what is the final answer? Does free will exist? Perhaps this is fundamentally the wrong question. Maybe we shouldn't ask, does free will exist? At what level, and in what way, do my choices hold meaning? The answer is, at the level you can experience, through causality, every choice you make holds meaning. On the macro level, within your subjective experience, you are free. You can think, hesitate, weigh options, change your mind, and take responsibility for your decisions. This freedom doesn't violate physical laws or transcend the chain of causality. It exists within it, functioning as part of the chain. On the micro level, in the quantum world, everything is a probability cloud, a superposition state, uncertain. At this level, the concepts of freedom and decision may lose meaning altogether, for even existence itself becomes blurred. At the cosmic level, within the four-dimensional spacetime of block universe, everything coexists simultaneously. Past, present, and future are static maps. Here, there is no change, no choice, only a complete, deterministic geometric structure. At the level of parallel universes, every possibility is realized. Each choice branches off into a separate universe, and every version of you truly exists. Here, the meaning of choice becomes which branch is the one you inhabit, yet all branches collectively form a complete inevitability. These dimensions are not contradictory. They are different facets of the same reality. Like a three-dimensional object appearing as different shapes from different angles, it remains the same object. Next time you agonize over whether to confess to that person, quit that painful job, or abandon a seemingly impossible dream, remember, in the realm of quantum mechanics, countless parallel universes may exist where you made different choices. In one universe, you mustered the courage to confess. In another, you chose silence. In one, you bravely handed in your resignation. In another, you endured another year. In one, you pursued your dream until success. In another, you opted for stability. But in your universe, on your timeline, only you bear responsibility for your choices. And that responsibility itself is the greatest freedom. Because responsibility means your choices carry weight, have consequences, and genuinely alter reality. A choice without consequence requires no accountability. It is precisely because your choices matter that they demand deliberation and the courage to bear their weight. Perhaps we can never philosophically prove whether we truly possess free will. Perhaps this question is logically unsolvable, like the Barber paradox. Like Gijal's incompleteness theorem tells us some truths can never be proven within the system itself. But we can choose to believe we are free and live accordingly. And this choice itself, choosing to believe, choosing to act, choosing to take responsibility, whether determined by the Big Bang 13.8 billion years ago, whether a product of quantum randomness, whether already etched into the four-dimensional map of the block, universe is the only reality you possess in this moment. Right now, your heart is beating, your brain is thinking, your consciousness is experiencing this instant. These are real, living, tangible things you can feel. That is enough. So, pursue what gives you meaning. Love those worthy of your affection, and do not dismiss love's value by thinking, perhaps it's just a chemical reaction of dopamine and oxytocin. Chase the dreams you desire. And do not abandon your efforts because success may have been predetermined. Experience this journey called life. And do not refuse to immerse yourself because perhaps it's all an illusion. Because whether the script is predetermined or not, the actor's commitment determines the brilliance of the performance. A great actor, even with a tragic script, can deliver a soul-stirring performance that moves audiences to tears, transforming tragedy into timeless art. A poor actor, even with the finest script, can only turn it into farce, squandering the story's potential. And you are that actor. Your life may be a script already written, but how you perform it, how much emotion you pour in, how many details you create, what memories you leave behind, these are all within your experience, shaped by your choices, and will become an eternal part of this universe. On the four-dimensional spacetime map of the multiverse, every moment of yours will exist forever. Your thoughts right now, your confusion, your epiphanies all become part of the spacetime fabric, an inseparable link in cosmic history. This is not insignificant. It is eternal. So live earnestly, love passionately, choose courageously. Not because you can change anything, but because your experience itself holds value. Your existence itself holds meaning. If this tale of the universe, time, and freedom resonates with you, it means that across countless possible parallel universes and timelines, you and I on this particular timeline have forged a connection in this moment. This connection, whether quantum entanglement, information transmission, or merely a fleeting resonance between two consciousnesses in an entropy-driven cosmos, is real. Hit subscribe, and let's continue exploring these fascinating yet terrifying questions. In the next video, we'll delve into what consciousness truly is, why you can never prove anyone else truly possesses consciousness beyond yourself, and why this question might be even more terrifying than free will, because perhaps, in this universe, you are the only one truly awake. Everyone else, including me, might just be illusions within your consciousness, elaborate illusions crafted by your own brain. But that's another story. Now, go make your choice whether it's predestined or truly free. Live your life in this branch of the universe, on this timeline, on this journey that is yours alone. Because in a universe of increasing entropy, on this one-way road where time cannot be reversed, every moment happens only once. And this one time that is all the meaning there is. And this one time that is all the meaning there is.